Okay, welcome back. And so today what we're going to do is we're going to discuss inverse functions. Okay, so we're going to start with an introduction, and then I'm going to give you the definition, and then the next video I'll do some examples of how do we use problems that would involve the inverse. Okay, so let's start with the idea that in inverse there are functions out there that can be paired up, where we can take a pair of functions where each function undo each other. Okay, and what do we mean by that? Well, let's look at the example here. And what I want to do is I'm going to take these two pairs of functions, and what I'm going to do is, as we know, okay, so these are functions, and we know that a function, whatever we put into here, it does something. It maps a value of x to another value of y. So it takes a value in the domain and maps it to a value, a specific value in the range. And so we know that if we take a number, let's say 10, and so if we take 10 and stick it into our function g, then what happens is, what g does is it takes that 10, multiplies it by 8, and then adds 5 to get 85. Okay. Now what we're going to do is we're going to take 85 and we're going to stick it into the new function f of x. And so now what we're going to do is we're going to evaluate f of 85. And what does 85 do, or what does f do? Well, f takes the argument, the value of x, and what does it do to it? It takes 1/8 of the value. So we're going to take 1/8 of 85. Okay? And, well, you know what I'm going to do? I'm going to rewrite this. I'm going to rewrite this just to make it easier to do. Well, I'm going to rewrite this function. Since it has a common denominator, I'm going to write this as x minus 5 over 8. Okay? So because I can write this as x over 8, right? And so, if I write it this way, then what's going to happen is, now what's going to do, I'm going to take x minus 5, and what am I going to do? It's 85 minus 5 over 8, which gives me 80 over 8, which brings me right back to where I started. So this is what I mean by they undo each other. So whatever g does to x, f undoes that operation. Okay? So it basically brings it right back to where we started. Okay? So that's going to be important because these two functions are what we would call inverse functions of each other. So g is an inverse of f, and of course f would be the inverse of g. Okay? And so that's what we mean by inverse functions. So what we're doing is basically, if you want a visual, it looks something like this. So again, here is the domain. Oh, you know what? I don't want to write that, because let's just do this. Let's go x1, x2, y1, y2. Okay? So now, the way we can look at this is that g takes x1 and let's say maps it that way. And what f does is maps like that. And so that's a visual you can have as far as what inverse functions do. Think about inverse operations like adding and subtracting, right? If you add and subtract the same amount, you basically have a net effect of 0, right? So those are what we call inverse operations, where multiplication and division are inverse operations. So if we multiply a number by 2 and then divide the product by 2, well, we get right back to what we started with. It was unchanged. Okay? Same thing with inverse functions. They undo each other. Okay? So again, I'm maybe over explaining that, but I want to make sure you guys understand what it is. Okay? So here's the definition. So the definition says that let f be a one-to-one function. So again, here's the thing. It has to be a one-to-one function. Okay? If it's not a one-to-one function, guess what? The inverse does not exist. But if it is an inverse, if it is a one-to-one function, then we know that an inverse function must exist. So anyway, so the definition says, okay, let f be a one-to-one function. Then g is the inverse function of f if both of these conditions are true, okay, or satisfied. What are the conditions? If we compose the two functions f circle g, so if we take f of g of x, okay, so in other words, another way to write this, again, just so you guys see this is the same as saying, let me write it this way. If we compose f of g of x. So we're basically putting g inside of f. So this is what we mean by composition of functions. We're composing the two functions. Okay, and similarly, this is defined also, oops, I keep putting parentheses where I don't want them. This would be g of f of x. Okay? So, what does this mean? If we compose f circle g of x and we get x back out, and again, and this has to be true for all x values in the domain of g, because g is inside f. Okay, so this has to hold for all value, for every x in the domain of g. And then likewise, if we compose it the other way, g circle f, then if this is true for every x in the domain of f, again, because f of x is the inside function, then if both of these conditions hold, then we know that g is an inverse function of f. Okay? So if this is true, then g and f are inverse functions of each other. Okay? So that's, and again, if g and f are inverse functions of each other, then we know this must be true. So it goes both ways. This should be an if and only if, because it's a definition. Okay? And that's it. So that's the idea of an inverse function. So next, what we're going to do is we're going to do examples. Okay, you could say this is sort of an example. But we're not going to do a couple of other examples of, hey, how do you determine whether two functions are inverses of each other? Well, guess what? We're going to use the definition. And the other thing, too, is how do we find an inverse of a one-to-one function? Well, first of all, it has to be one-to-one. Okay? But if it is one-to-one, then we know that the inverse must exist. And how do we find it? That's coming next. Okay, have a great day.